Yay! Okay, so first thing, okay, you have an inscribed polygon and a circumscribed polygon. What do you think it means for a polygon to be inscribed? Inside the circle. So draw whatever kind of polygon you want inside of a circle. Okay, so an inscribed polygon is a polygon drawn inside of a circle such that each vertex of the polygon touches the circle. Okay, what do you think a circumscribed polygon is? On the outside of the circle, so good luck drawing it, but something like so. Yes. So mine's not very good. I accidentally went inside the circle up here, but everything should be on the outside. Okay, so it is a polygon drawn outside a circle such that each side of the polygon is tangent to the circle. Okay, and where it touches the circle, what do we call that?
Point of tangent.
Point of tangency. Very good. Questions over our definitions? No? Okay. In that next little area, we are going to write down a theorem or a rule. Okay, a triangle that is inscribed and goes through the center is a right triangle. So anytime you have a triangle inscribed that goes through the center, it will always be a right triangle, which means one of the sides is always the diameter. And that makes sense because in example 1, which angle would be inscribed? C. And C opens up to what measure of arc? 180, because it opens up to this semicircle, okay, which makes it 1/2 of that, so that makes C 90 degrees. So anytime you have an inscribed circle that has a diameter as a side, then one of those angles has to be 90 degrees, resulting in a right triangle. Okay, so I'll do number 1 with you, and then you guys can do 2, 3, and 4 real quick. But if measure A is 55 degrees, C is 90, then what would B be? 35. Okay, so real quick, solve 2, 3, and 4. Okay, what would be the measure of angle A in number 2? 28. Number 3, the measure of angle A?
52.
And 4, the measure of angle C? Any questions on that idea? That any triangle inscribed that has a side as the diameter is a right triangle? Any questions on that? Okay. Alright, you're going to write at the top of your page in what little room that you do have. Okay, another theorem. Okay, is that if a quadrilateral is inscribed, then opposite angles are what? Any ideas? Not congruent. Supplementary. Very good. It's usually one or the other. Okay, so if a quadrilateral is inscribed of a circle, the opposite angles are supplementary. Okay, so if angle B is 81 degrees, what would angle D be? Very good. Do 6, 7, and 8. What's the measure of angle A in number 6? Very good. Measure of angle B in 7? And C in 8? Very good. Any questions on that? Okay. Alright. The next one incorporates that last rule that we talked about on secant and tangent day. And what did we say happens if two secants meet at an external point? What happens to their tangent segments? They're congruent. Okay? So, if all these points are points of tangency, okay, if from here to here is 10.5, what is the distance from here to here? 10.5. And that is the big idea for this part of the note. So if this is 11.2, then from here to here would be what? 11.2, resulting in the remaining piece being 12. And then this piece up top would be 12. And then to find the perimeter, what would you do? Add it all up. So 2 times 10.5 plus 2 times 11.2 plus 2 times 12. What do you get? 67.4 units. Very good. Okay, does that make sense? Okay, so if they meet at an external point, okay, then the two tangent segments are congruent. Okay, always start with the small pieces and label all those and then work your way backwards, because a lot of times they're going to give you a side that isn't broken in half yet or broken into 2 pieces yet, and you have to use all your other sides in order to figure out those exact side lengths. Okay, so for number 10, I have 13 and 13, resulting in the left-hand side being what? What would be this length? 12. And 12, making this bottom right side what? 9.8 and 9.8. So I have 2 times 13 plus 2 times 4.6 plus 2 times 9.8 plus 2 times 12. The biggest thing here is don't forget any sides. You should always have 2 of everything. What is it? Very good. Okay, try 11 and 12 on your own. Okay, what'd you guys get for 11? Very good. And 12. Very good. Any questions over today's lesson? Super short and sweet. Any questions?